Okay, let's do problem number 42 on the 1988 E&M multiple choice AP Physics C exam. Okay, so I'll read the problem. It says, two very long parallel wires carry equal currents in the same direction into the page. So here we go. Here's a wire and it's going into the page. Here's a wire. It's going into the page. At point P, which is 10 centimeters from each wire, so this distance and this distance are the same, the magnetic field is, so we want to know what is the magnetic field here. And here are our choices. 0, directed into the page, directed out of the page, directed to the left, directed to the right. Okay, the thing to remember is these are long straight wires, right? This is a cross section of a long straight wire, and it's got a current going down like that, right? So what are we going to do? We're going to grab these wires with our right hand, and what's straight about a long straight wire? Well, the wire is, the current is. So what curls? The magnetic field. So imagine this is like this, okay? Here's your wire. My pencil's going to represent the wire. Here's my right hand, and I'm going to grab it so my thumb goes down. In what direction are my fingers curling in? They're going around clockwise, right? Clockwise. So that means that at this point, we have a magnetic field that's going around like this clockwise. Okay? So due to this wire, just draw a radius out like this and then say, okay, the magnetic field due to this particular wire is tangential to this circle. I mean, your magnetic field line is a circle. But at that point, you would say, oh, the magnetic field is in this direction and has a certain magnitude. Yes? Okay. Now we're going to do this wire. We're going to do the same thing to this wire. So here's your wire. Your current is going down. I'll hold the pencil with my left hand. Here's my right hand. My thumb goes down. It goes, so it's, again, it's just circulating clock. So let's do that. Here's a circle. And it goes around like that. So the magnetic field due to the current in this wire right here is going tangentially off like this. So this one's going like this, and this one's going like this. Well, what is the net magnetic field right here? You just add these two together. You have to add them as vectors. So I'm going to pick this one up and set it down right there. So I just pick this magnetic field vector and put it up over here. So this one plus this one equals this. Right? So this vector, because, okay, magnetic fields, electric fields, whatever, if you have multiple things, the nice thing about them is that you figure out what those fields are due to each individual thing, and then you just add the fields together. You just take the vector sum. So that means that the vector sum of these two guys is this, which is to the right and on the page. So directed into the page, no. And it's not 0. Directed out of the page, no. Directed to the left, no. Directed to the right, yay, there it is. And that is how you do number 42. So again, what's the big idea? Big idea. Well, first of all, you have to be able to draw the B field for long, straight, am I off screen? Yeah, long, straight wires. Right? If you have a long, straight wire, and the current's going like that, you grab it with your right hand, and your fingers circulate around in the direction of the magnetic field. So this magnetic field is going to circulate down in front and back like that. You kind of have to think in 3 dimensions. So this is closer to us. This is away from us on the other side. Right? With it. And you have to understand that magnetic fields, if you have more than one wire, if you want to know the magnetic field of a particular spot, that B fields add. That is, they obey the principle of superposition. You might hear that, superposition. They add up. So that is number 42, beaten to death. Any questions? That is all.